Welcome to an introduction to Procs, Lambdas and closures in Ruby. Thought you'd like the typo there, gives it a little bit of flavour. This is really a short side section of my Ruby Reloaded course, but you may be viewing this in some other way on YouTube or whatever, so hello everyone. Feel free to check out the course at rubyreloaded.com if you are not part of that course. I'm frequently running Ruby training courses on there, so you might find that interesting. So, something I needed to do a video about was, in Ruby, what are procs? What are lambdas? What are closures? How do they all kind of work with each other? How do they all relate? Now, I'm really going to stick to the basics in this video, just enough for you to start playing along and to hit up deeper tutorials that are available out there. There's so much stuff out there, but I'm going to look at a few little tricks along the way. So, rather than start with a dry definition, let's get there with some examples. So you should be familiar with the concept of a block in Ruby. Blocks are essentially nameless functions of a sort. So let's just give one a whirl so we get a little bit of a feel for what's going on. So what I've done here is I've created an array. It contains the numbers 1, 2, 3 and 4. I then have the each method on that array, and then I pass that a code block. So that's the section here between the do and the end. And if I save this and run this, you won't be surprised to see that the result is 1, 2, 3, 4. We could also write that in a slightly different way, as you're probably aware, using curly braces. I'll just do it manually here so you can see the process there. This is kind of the recommended way of doing it if you're going to do things as a one-liner. And as you can see, that runs in exactly the same way. So as I said, behind the scenes, each is essentially an iterator method that's available on the array class that accepts a code block that's passed to it. So we've got our code block here that prints something out. And for each element of the array, that code block is run. So that's why we get to see 1, 2, 3, 4 come out. That code block is run for each thing, for 1, for 2, for 3, for 4. So it's all being dynamically run multiple times by another method each behind the scenes. Now this demo already shows off the idea of blocks as nameless portions of code. You can think of them as functions if you wish, that can be passed pretty much anywhere and then which can be run arbitrarily. Most often in a loop abstraction scenario like this one, so where we've gone over something a certain amount of times. Now, the interesting leap that we can make here is that we can make our own methods that accept blocks in a very similar way to each, and then does stuff with those blocks. So we'll start with the most simple, most useless almost example by creating a method in the main context. And I have an example ready here. So what I've got here is I've got a method called runBlock, and all it does is call a method called yield. We'll get to that in a second. And then we have a call to runBlock, and we're passing a code block. So again, this could be curly braces all on one line, but we'll just do it with a do and an end. So what's happening? Well, if we just run the code, it prints out hello world, that's fine. What's happening? Well, when we're running runBlock here, we're essentially calling the runBlock method, passing it this code block, and then yield is another method that essentially yields control to a passed block that's within the current context. But what happens if we don't pass a block? So what happens if I just get rid of the block and I run that? We get an error, an exception of a local jump error, no block given on the yield. Why is this occurring? Well, yield is looking for a code block's been passed to the current method. It can't find one, it fails. Luckily, however, there is another method that we can use to check whether a block was given to a method or not, and that is called block_given query. And if I put this, it will only run yield if a block was passed. So if we run it now, pretty much nothing occurs. So let's extend our example a little bit now. Again, I have another example here. Let's add a random_each method to the array class. So we'll do a bit of a monkey patch here. And it will work a little bit like each, like we did in the first example, but it will go through an array in a random order. So if we jump to this, what I've done here is I've opened the array class, and then I've created the randomEach method. I've used array's built-in shuffle method to shuffle up the array into a random order. I'm then using its normal each method and passing it this code block here, which then in turn yields to whatever code block has been passed into randomEach with each element of the shuffled array. So what's happening here is I've created an array, contains 1, 2, 3, 4, 5, and then I call random each. To random each, I pass along this code block that prints out an element. So this code block here ends up being attached to random each essentially once we get into this section here. It does the shuffle, it loops over, and then it will yield to this block here for each element that comes out of that shuffled array. So if we run that, we get 5, 3, 4, 2, 1. It's all in a random order. Now, there's another way that we can write this that will allow us to get a bit of a tighter grip, a bit more of control on the code block. So let's see. I have another example here. Now, this is slightly different. In this case, we're using a special format here in the list of parameters. So normally you'd have a list of your parameters here, but then at the end what you can include is you can include an ampersand and then an argument. So what this will do is any code block that's being passed along, it will assign to this variable. So B will essentially become a reference to that code block that's being passed here. So within the random each method now at this point, when we run this code, which as you'll see runs pretty much like the last example, B now represents that code block. So we're not implicitly calling it with yield or something like that or checking with block given. We are now using B explicitly. So that's what's happening here. We're doing B.call and then the element that we want to pass in as the parameter here. So what's going on here? What is B? We've managed to get an object obviously at this point. What is B? So we can check this by using the P method to kind of have a little bit of an inspection of B. And if we run this, we get, that comes up here, a proc. So it's a proc object, and we've now pretty much got to the definition of what a proc object is. It's essentially a nameless, or as it's often called, anonymous function or block of code that can be represented as an object and can be passed around and called at will. But there is a key difference between procs and blocks that we really need to check out. And that is that you can only pass a single block to a method at a time. So this is pretty much a baked-in restriction in Ruby. But what you can do is you can pass multiple procs around, as parameters to, in methods, because procs are regular objects, so they can be passed around like an array or a string, whatever you want. And there's a little demonstration here. So what we're doing is, ignore this method for now. We create a proc. And see this syntax here, we're actually using proc.new now to actually create our proc. And all the proc's doing is it's just saying, pretty much hello to the world here. This is proc1 and this is proc2. So we have two procs, and we are calling the run2procs method, and we are passing in the procs just as if they were any other type of object. So if you see here, we now have this method. It's accepting A and B, so it's bringing in proc1 and proc2, assigning them to A and B, and then we can literally just do an A.call and a B.call, and everything's pretty much good to go. So, pretty handy. Now, I need to show off one interesting trick at this point, because you may encounter it in Ruby code that you're looking at that's out there. Essentially, if you have a method that's being passed a code block, as we saw earlier, you can call it with yield, we saw that, or you can use the ampersand argument to convert it into a proc, which you can run within the method. We've seen that as well. There is, however, a third way. And let's look at that here. So this is very similar to one of the prior examples that we had. We have a method called runBlock, and we call runBlock. We pass it a block. But instead of accepting something in here or using yield, you kind of get a little bit of a mixture of the two. We haven't actually had to put any specific parameters up here, or an ampersand parameter or whatever. All we've done is we've called proc.new. And the reason this works is that if you use proc.new without giving it a code block to assign to that proc, proc.new will look to see if the current scope has been passed a code block, and then it will use that. So, and it will do this all implicitly. I haven't had to specify anything here. The fact is, I've not put another code block in here, so it's going to, pretty much look for that for me and then apply it. Now, if you try to do it in a scope that's not been passed a code block, it will raise an error. So we can sort of very quickly prove that. Get rid of this and run this, and it says, we tried to create a proc object without a block. So essentially, proc.new wants a code block to use, whether it gets it directly or it kind of implicitly picks one up from the current scope, the current environment. Now, in Ruby 1.9, there are 4 main ways to call or run a block. So let's look at each of them quickly. Now here we're just defining a proc. It has one parameter, a, and then it just prints out this is my proc and then puts in whatever was passed to it. And we've called it my_proc. So here's the first way that we can call it. We can use the call method. We've used this in prior examples, and we're just passing in 10 as the argument here. Another way, and this isn't a typo, it might look a little bit like one, we use dot, parentheses, and then arguments. And what happens behind the scenes, this is kind of an interesting one actually, is that actually gets converted to a call. It's basically a synonym for calling .call. It will even work on non-proc objects if they implement a call method. So it's a little bit weird. It's a little bit of weird syntax trickery going on there, but that's another way you can get in. Another way is to use square brackets, and last but not least, you can use triple equals. And that might seem a little bit weird to you, but let's just run this just so you can see that this is definitely working. We get this is my proc and 10 and 20, 30, 40. So what's this triple equals thing all about? Well, in Ruby, that triple equals operator is called the case equality operator, and its primary function is it gets used within case statements, and I mean it does have some other uses as well, but case statements is pretty much the reason that this came about, this syntax specifically for procs anyway. So without going into too much detail, here's a little explanation, a very contrived demo for you. Now we've created quite a few procs here. We've created procs that have been assigned to variables called several, many, few, couple, and none, which will give a little bit of a clue about what they're checking for. They each have a single parameter, which is number, and that comes in, and all we do is we just do basically a logical check in all of these cases. We check to see is the number above 3 and less than 8, and if it is, the several proc will return true or false accordingly. We check to see whether it's above 3 and under 8 for the many. For few, we check to see that the number is exactly 3. For couple, 2, and none, 0. And what we do here is we loop around the numbers from 0 up to 10. And again, we're using a code block here, but we don't need to worry too much about what this code block does because up to is handling that. And we get number coming in, we say that number items is, and then we set up our case statement. Now, hopefully you're familiar with case statements. If not, this may seem quite confusing to you. But what essentially we're doing is we're saying, query our number at this point. And then what normally happens in a case statement is, if we had something like, let's say we wanted number 5. If number is equal to 5, now print several. So we'd use this kind of construction. Then what would happen behind the scenes is we would have 5 equals number. So that might seem a little bit back to front, but this is what happens in Ruby. So it takes each thing, goes through the list, and then it takes the actual object here, does the case equality operator, and then whatever it is that is the subject of the case statement. So what is happening when we have this type of arrangement? When several, when many, when few, and so on and so forth. Well, we come in, and first what it will do is it will take several. So I'll create a little comment here. It will use the case equality operator upon it, and then it will have number. But rather than actually doing any kind of equality check, as it would do if we, had a number or something along those types of lines, what happens is it takes the several proc and it calls it passing in number, so number makes it to here. It checks to see, is this true or false? If it's true, it will run this piece of code. If it's false, it won't. We'll move on to the next thing. And so that's really what's going on here. Now, if you have used case statements a lot, you might say, well, we could have just used a range here or something along those types of lines. We could have said, 4.7 or something along those lines, because 4.7 equals say 5 would then come out to true. But we've managed to abstract everything away into proc objects, which are then being called behind the scenes, essentially, using that case equality operator by Ruby. So this kind of clever trick allows you to abstract away interesting bits of functionality. And I must admit, I've only use this a few times really in any kind of actual live scenario. It's not something that I'm always pulling out of the bag, but it's really worth knowing about this, and it's a nice little trick. So let's move on to lambdas. What are they? Well, they're essentially just proc objects. That they are proc objects. Don't worry about that. But they have a couple of different behaviours, so this distinguishes them from just plain old procs. Now we'll start off with a simple demo. So what we got going on here? Well, this looks a little bit like our system where we had a proc.new and that type of thing. Have some code in there, call it. Nothing too surprising. Well, what I can do is I can change that proc.new to lambda. And just as a quick aside, actually, I don't have to just change it to lambda. I could change it to proc. And that is actually a shortcut way of pretty much doing the same thing that proc.new does. So it's a shortcut way of just writing essentially the same thing. The reason why you might not want to use it is because in Ruby 1.8, writing proc will actually create a lambda. So it gets a little bit confusing. But in 1.9, it's treated, pretty much the way you would expect. But back to lambdas. So let's run this code. You'll see it works in exactly the same way as it did with the proc. So what is the difference? Well, one key difference is that lambdas enforce arity. What does that mean? It essentially means that lambdas are very particular about having the number of the parameters and the number of arguments involved match up. So a lambda expects to be called with as many as it expects to receive. I'll just quickly show you a demo because, again, that is always the best way of showing things off here. So what I've got is I've got a lambda. We have 3 parameters in here, A, B, and C. But when we call it, we're not actually passing in anything. So there's nothing for A, B, and C to receive. So if we just run this, it says wrong number of arguments, 0 for 3. So it's a lot like a method in that respect. It's not going to sort of stand for any nonsense in that regard. Whereas if I change this, and remember this is 1.9 the way we're doing this, if I change it to proc in this case, it works fine. And what's happening in this case is that A, B, and C will be set to nil because there's nothing for them to grab, so they'll just default to nil. Whereas a lambda acts a little bit more like a method with its parameters, and it will just give up and throw that exception. So another key difference is in lambdas and procs return semantics. So again, another really quick demo. What I've got here is I've created a single method called runAProc. It accepts a proc, comes in as P, and what we do is we say, literally, we print to the screen at this point, we're going to start running a proc, we call the proc, and then we say we finish running the proc. So if we break this up a little bit, the first thing that we do is we call runAProc and we pass in a lambda that prints it itself. It will say I'm a lambda, and then there's a return. So a bit like you would do in a method, we have a return within a lambda here. And then what we have following up with that is we have exactly the same thing, but with a proc instead of a lambda. So this is a plain proc object. Now if we run this, with the lambda, we make it into runAProc. It says starting to run the proc, it says I'm a lambda, and then it says finish running the proc. When we use the normal proc, however, the bare bones proc, it will say starting to run a proc, I'm a proc, and then whoa, exception, unexpected return. What's going on here? Well, the reason for this is that a return in a proc will try to do a return from the context of where the proc was defined. So not where it's currently running, where it's actually defined. So since that's in the main context, so we've actually defined the proc here, this return is trying to return from our scope out here, which is the main context. And you can't return from the main context, so we have a big issue on our hands. But we can tweak this to actually, reach the end of the program. So what we'll do is move on to this. What I've done is, this is really, really simple way of doing it. I've created another method called OurProgram, which I call later on. So this is just really wrapping this up very simply. We, again, do exactly the same thing, run the lambda, run the proc. And if I run this, you get to see the lambda, in, runs, out, fine. The proc, in, says I'm a proc, but we never see finished running the proc. And the reason for that is that when we get to this point, we pass the proc, makes it into here, we print out starting to run a proc, p.call, but because it's doing a return, procs return from where they are defined, that context where they're defined, which is here. So at this very point, when we've done this call, it's returning from here back out and exits our program. So that's why we never get to this line here. Now, I just have to do one little change here that will really show this off for you. So we'll just quickly do a little test of this. So we'll switch around the proc and the lambda. This will really show you the kind of how far this technique goes. We'll run this one, and all it does this time is starts to run a proc, I'm a proc, and we see no more. We don't even see the lambda or anything like that at all. So literally at this point it's run this, it's pushed in this proc up to here, calls it, the return drags us right out of our program and then back down to the bottom here where the program terminates. Now at this stage, before we move on to closures, which is the next thing we're going to deal with, I just want to recommend to you that you check out a page in the Ruby documentation. So all you need to do is search for Ruby Proc and Google that. The first result is usually at the Ruby doc site, and it will show you the documentation for the proc class, and it has some pretty interesting methods on there. Now remember that procs do include lambdas, even though they are just a slightly different flavour of procs. And there are a few interesting methods there, including a lambda query, which allows you to ask a proc, are you a lambda or not? That may be useful to you. And also source location is one of my favourites, which tells you which file and where, what line and everything a proc was defined. And this can come in really handy if you want to make your own little testing library, things like that. And if you were on the Ruby Reloaded course, you would have seen how I put together the test rocket testing library that I developed, and I pretty much used that source location method to good effect. So, closures, what are they? Well, in Ruby, a closure is very much like what you've seen already. So you take something like an anonymous code block or function, something that's in a proc object, but one that maintains references to local variables that were present and being used at the time of the definition of that code. So as with everything else, demonstration is probably just what we need here. So this is quite simple. What we've done is we've got a local variable called name, and we make it point to a lovely string object that contains the name Fred, and then we have another variable here, printer name, which is associated with this proc object, that all it does is it just prints out name to the screen. And then we have, you've seen this a few times, a runProc method that just accepts a proc as as an argument, comes in and runs that with the call, off we go. Well, may think, yeah, this will work fine, we'll just run this, it'll print Fred out to the screen. But if you think about it really logically, name exists here. It doesn't exist in this scope here. So when we're doing this puts name, something magical must be happening so that when this proc makes it into P and then it's being called, that magically makes name kind of come back to life and we can access it once again. That kind of magic is called a closure. So what's actually going on here? Well, as you can see, once we define name, we do the puts name, name is treated, put into the closure. It can tell that we're actually using name within that proc, and that's why it all kind of gets boiled in. And that's why it will hang around as part of the proc and means it can be used later. So let's just look at perhaps a slightly more interesting example, which shows how we can use a closure to dynamically define function behavior. So I quite like this one. This is a common example you'll see in a lot of the books. So what I've done here is I've created a method, it's called multiple generator, and this is a method that will actually create a lambda object for us. And what we do is, all you just do is pass in a number, so that's a multiplier. It creates a lambda, which in turn accepts a number. It multiplies that number by the multiple that's come in through m, and that's it. Very simple. So what I've done is I've created a doubler and a tripler. So all you do is you call multiple generator with 2 and 3, and what that will do in turn is it will create a lambda that accepts a number and then takes that number and multiplies it by 2 in this case, or by 3 in this case. So what's actually happening is when we're calling multiple generator 2, m comes in and then exists, so we've got m is equal to 2 at this point, and then m is stored within the closure of this lambda. So then that lambda can then be used later on, as it is here, with puts doubler 5. That could be .call, but we've just used the square brackets for just a little bit of a change here. And then what that will do is it will print out 10. And if we take the tripler, because 3 is now m, we get 30. So if we run that, pretty much as expected. Now, Ruby's closures have an interesting behavior compared to some other languages, which some other languages, their closures will be implemented with a data structure that stores the variables and their values at the time the closure is created. But in Ruby, merely a reference is kept to those variables. So it means that the contents of those variables can be changed before the proc gets a chance to run. So let's jump back to a copy of a prior example and see that in action. So this is a lot like the example that we did just a minute ago, where we take a name, we print out that name in a proc, but then what I've done is I've changed what name is equal to at this point from Fred to John. So you may think, well, okay, at this point the closure was formed when we defined the proc, so it might set name and it will be Fred forevermore, so once we do p.call it will print Fred. But because of what I've just explained about it keeps a reference to the variable rather than the value of it at the very time, what happens is we run this and we get John. So in this case, name became part of the capture, but because the value then changed and Ruby keeps a reference, the updated value is recognized as name's value in the closure at the time it is called as well. Now, obviously there's a lot more to closures than this, but that is the very basic introduction as to what they're all about. And if you are part of the Ruby Reloaded course, or actually even if you're watching this on YouTube and you want to leave a comment or something, feel free to say if you want to see perhaps a slightly more advanced video digging into a specific thing. I really wanted to just provide you with the basic vocabulary here and the basic example so that now when you encounter these sort of things you understand roughly what's going on, rather than perhaps looking at some of the weird edge cases that you almost never bump into in production code. So this will get you quite a long way, but if you are part of the course or whatever, come into the forum, request a video, more than happy to produce it for you. So that's it for now, a very basic introduction to blocks, procs and closures. I hope you enjoyed it.